Good morning, Bears. It is a Tuesday read-along, close read day. Tomorrow, I think we're going to play a little simulation video games on the water cycle. And then on Thursday, Friday Epic, we'll move into renewable energy, maybe doing a quick version of taking LBMS off the grid with renewable energy, using a map of LBMS, putting solar power, geothermal, whatever kind of energy you think is best, and we're going to take Luther Burbank off the grid. Oh, yeah. Mr. Downs has a little bit of back pain today. I don't know what's going on, but I strained a muscle, and it is painful. But we're going to fight through it and get this done. So Melody, Top Gun Melody, way to get it done and open up your slideshow. She's got her basics going. She's got the words on every slide. That's a good start. All you have to do is go find visual images to support. So, for example, fossil fuels, look up a picture, put it in there, and you're ready to go, as Brandon has done. Now, Brandon, there's by Brandon. Look at that. He's even got that done. Good job. So the water cycle. What is the water cycle? The game you're going to play, you will play with this water cycle tomorrow. Today, we're going to talk about clouds. Clouds are fascinating. There's a bunch of them in the air today. You can look outside. You can study them live. See if you can identify different types of clouds after today. Condensation builds clouds. Precipitation, it rains down. We have runoff, water on the surface. It collects. And then with enough heat from the sun, you get evaporation. That's a basic elementary level water cycle. You are going to get a little more advanced in your thinking, but the water cycle, also known as the hydrologic cycle or the hydrological cycle, describes the continuous movement of water on, above, and below the surface of the earth. You make this slide, you look, you learn, you know the basics of water cycle. Precipitation, interesting. Not sure what this file represents. In aqueous solution, precipitation is the process of transforming a dissolved substance into an insoluble solid from a supersaturated solution. The solid formed is called the precipitate. Interesting. That's a whole new version of precipitation. But it basically is taking vapor and making it, even though water's not a solid, it's a liquid, but it is taking something liquid into a solid, like a precipitate, or taking a vapor into a liquid. Good job. Evaporation is the opposite of precipitation in a way. It's a type of vaporization, vapor, that occurs on the surface of a liquid as it changes into the gas phase. The surrounding gas must not be saturated with the evaporating substance. When the molecules of the liquid collide, they transfer energy to each other based on how they collide with each other. Good, good, good. See what I'm talking about? Going deeper. Remember, every single thing from our skin to the air to the water has little tiny molecules. If the molecules are moving slow enough, we are a solid. If the molecules speed up, it becomes a liquid. If they speed up enough, it becomes a vapor. This is silver. This silver ring could become a liquid if we heated it up. Not sure the potential that this could ever be a gas because can't do that. But liquid can, gas from the car can. There's a lot of different liquid forms that can become gas that can never become a solid. There's a lot of solids that can become liquid but never make it to gas state. Now, think about a volcano. That's rocks. It seems weird to think rocks could actually be liquid, but it can be. So the molecules in this, heated up to the right state, would flow, and as a matter of fact, that's how they make the ring. They make a cast, they pour liquid in, it cools and becomes a ring. Now the stone, turquoise, we could look up, may or may not, this is getting to do a little geology, but see that little dark there? That's a different type of stone. That's not turquoise. So we have turquoise that became a shape underground. It could have been from metamorphic pressure. That's heat from pressure, so much heavy rock that it actually turns liquid and can make shapes, or from heat from another source, like from the mantle of the earth, from the core of the earth, so much heat that it could become liquid. It flows. When it dries, it becomes a rock, and that dries, cools, it becomes a rock again. Little side lesson there with my ring. Good job, buddy. How much you can learn so much from slideshow. Condensation is the change of the physical state of matter from the gas phase into the liquid phase and is the reverse of vaporization. The word most often refers to the water cycle, yes. Now remember, condensation, usually it can condensate into the clouds up in the air. It can also condensate onto a leaf or the top of your car in the morning. Sometimes you walk out and you're like, it didn't rain, but there's water dripping off my umbrellas. That's the condensation in the air forming on the material of the umbrella and then flowing off. But condensation also affects clouds, which we're studying today. Transpiration. This is the most complicated one in a way. In a way, it's like perspiration. When you sweat, it's kind of like that for a plant. Transpiration is the process of water movement through a plant, and it's evaporation from aerial parts such as leaves, stems, and flowers. Water is necessary for plants, but only a small amount of water taken up by the roots is used for the growth of metabolism. The remaining 97 to 99.5% is lost by transpiration or glutation. Interesting. Fantastic. We have runoff, which is kind of the most basic. If water hits a hill, it's going to run off into the ocean. Now, much of it does infiltrate into the earth. So the earth does soak it up, and mountains will soak it up, and it'll take a long time to make its way through the ground. Like the one video said, it could be thousands of years for that water deep in the ground to actually make its way out, because it's not going to evaporate because it's not exposed to air. But up here, it's going to evaporate on the way down, but it's also going to run along rivers and down back to its source. Beautiful. Now, we're going to do the rest of these starting Wednesday when we move into solar power, but it's awesome. And we're going to take LBMS off the grid in a little project. All right, let's dive into our article today. Your article, as always, is in groups. I hope it works. Don't worry about these sims. We're going to do that something different. Instead, I found a more fun game. All right, remember, when you read along with a read-along article, it is so important to read along. Listen, learn, and read. You will become a better reader. Maybe you're not sure how to say temperature. Well, now you're going to know. So we're going to follow along with this. We want to get 3 to 5 notes. We're just writing an informational CER today, informational essay. Now, you can make it a claim essay, a FIST essay, entertaining essay. You could even write a story about clouds. One day, I woke up and I went outside and I saw the cumulus clouds floating throughout the sky. So you can, any way you want to write a story, CER, essay, FIST essay, informational, persuasive, why you like clouds. You could even write a poem about clouds, but try to use 3 pieces of information from the source. Now, if you're writing a poem, you might want to, you could still citation from the poem, but you just use the information. So as we go through now, or at the end, go click the link, come back into the article, and find 3 things you can highlight. We all remember how to highlight, and then you make a note, and your highlight is the citation, the note is your explanation or reasoning, and you building your CER as you go. Remember, you can copy it to put into your top slide. So top slide on clouds, here we go. If I can get there. Oh yeah, here we go.
What are clouds? Looking up at the sky. Dr. Joanne Simpson became fascinated with clouds at an early age. Simpson would grow up to study clouds and become the first woman to earn a PhD in meteorology. But as a child, she simply loved how they looked. When she was a young girl, walking around her town and sailing on the nearby ocean, she noticed all kinds of unusual clouds. She saw clouds that looked like towers looming high, bunches of hanging grapes, and even UFOs. She wondered what they were made of and how they formed so many different amazing shapes. When Simpson went to college in the 1940s, nobody thought clouds were important for scientists to study. However, Simpson's professors encouraged her to study clouds because she was a woman and they didn't think women could be serious scientists. Clouds seemed to them like a good, unimportant subject for a woman to study. Simpson went on to prove her professors wrong about both clouds and female scientists. Determined to succeed despite sexism, Simpson continued her study of clouds and...
I always like to pause in the pictures. Joanne Simpson photographed and collected observations, evidence about all kinds of clouds. Now that's kind of cool, like a groundbreaker. And this is fun. This is a primary source. You can tell it's a photograph of her studying clouds back before computers. I don't see any computers. Look at all that paper and rulers. Everything had to be done by hand. Drawings. Look at all those folders. Totally different historical peek into the history of science right here as a side note. Very cool.
in cloud formation. She collected data as she flew in airplanes high above Earth's surface, taking notes and sketching in her field journal to document the cloud formations she saw. Most interesting of all to Simpson were the gigantic clouds she called hot towers. These cumulonimbus clouds look like skyscrapers sticking up above the clouds around them. Simpson wanted to know why hot towers were so unusual, so she set out to study them. She collected data about the temperature, wind conditions, and amount of water vapor in these unusual cloud formations. Eventually, she was able to explain that hot tower clouds form when warm air with lots of water vapor in it rises.
Now, if you're reading along with me on your own, or you go back, this is kind of a cool little science fact, so you might grab it. And then you could highlight it. And then later you could come back and study it again and then make your comment, or you can copy and paste it. Because remember, we're making a top slide on clouds. Clouds are fantastic. Poems are fun about clouds. Let's keep going.
Quickly from Earth's surface into the troposphere, the layer of the atmosphere closest to the Earth, cooling as it goes. Based on her research about hot towers and other kinds of clouds, Simpson is considered one of the most important weather scientists in the history of meteorology. What all clouds share. Research by meteorologists like Simpson shows that all clouds, even the most unusual types, have a lot in common. Meteorologists use a helpful concept, the idea of air parcels, to study all kinds of clouds and track them as they move through the troposphere. An air parcel is an amount of air that moves as a unit. All clouds form when the water vapor in air parcels comes into contact with colder surrounding air.
That seems like a pretty good note right there. All clouds form when the water vapor in air parcels come to contact with cold surrounding air. Now you can do your own highlights. Now remember, so this is how you would do this, because remember, all you need is 3. Now you click it again, you take a note, you go, all clouds form when the water vapor in the air parcels come into contact with cold surrounding air. Maybe you want to ask a question. I wonder what makes this happen. Maybe it has to do with molecules. So you can ask questions as well. Now, it's up to you if right during this moment you copy this, put it in a slide, copy this, put it in a slide, or you go back later and do it. So you have different ways to kind of get your research done.
When it meets the colder air, the water vapor in each air parcel becomes liquid in a process called condensation. In fact, all clouds are made of the same basic ingredient, visible droplets of water floating in the troposphere. If it's cold enough, the water droplets can freeze into tiny ice crystals. How does water vapor get into the troposphere in the first place? It comes from liquid water on Earth's surface. When liquid water gets warm enough, it turns into water vapor through a process called evaporation. The water vapor becomes a part of the air and is ready to become part of a cloud when the conditions are right. Cloud formation and energy. Cooling is an important cause of rainfall. Cooling air parcels can cause clouds to form and rain to fall. What causes an air parcel to cool? The process is driven by energy. When a warm air parcel is surrounded by colder air, the energy from the warm air parcel is transferred to the colder air until the temperature of all the air is equal. While an air parcel is losing energy, the temperature of the air parcel decreases. The energy transfer that causes the warm air parcel to cool can also cause the warm vapor in the parcel to condense into liquid water. This liquid water is what forms a cloud. The more energy the air parcel loses, the more it cools and the more liquid water it forms, making more rainfall possible. When the droplets of liquid water in the clouds become big enough, they fall to the ground as rain. JoAnn Simpson's legacy. JoAnn Simpson started.
Take a look at our diagram. The diagram shows how energy is transferred during cloud formation. As energy is transferred out of an air parcel its temperature drops. Remember, this goes back to when we learned about energy. Energy moves, temperature drops. Loss of energy, loss of temperature. When the air parcel has lost enough energy to become cold enough, water vapor in the parcel condenses, forming a cloud. Fascinating.
Her career focused on the beautiful shapes she saw in the sky, wondering how and why the amazing clouds that she saw might form. Simpson's curiosity as a child led her to a pioneering career in the field of meteorology. Her work helped us understand how energy, evaporation, and condensation form the clouds that we see in the sky. Meteorologists today still make use of Simpson's work as they study the weather.
Wow, that's an awesome one. All right, so look at that beautiful picture. There's a lot to study on clouds. You're making a top slide on clouds. It's fun. It's beautiful. You could make a story, CER, informational essay. Use information from the article. If you're doing a CER, it's pretty classic. Make a claim about clouds, say how they're made, find evidence from the text, copy a couple citations, explain it in 5 to 7 sentences, FIST essay. All right, let's do this. Tomorrow we play some simulation games, and then we take LBMS off the grid. It's a great week. Have a good day, everybody. Let's do this. Top slide on clouds.